Okay, so let's talk about domain a little bit more. Here's what we did yesterday. First thing is it a function or not? Because if it isn't even a function, then we don't even talk about its domain. So is this a function or not? Yep, because it passes the vertical line test. All right, there is a horizontal line test, but we aren't going to do that until we talk about inverses. All right, circles. We called them a function last year, but they aren't. Because why? They don't pass the vertical line test. And last year, when we did circles, I hope you did circles in your HA class. Yep, you may. We had them in two different parts, like that part of the circle and that part of the circle, because separately, they are functions. So if you divide it into two half circles, excuse me, unless you're talking about circles and how they're functions or not, then it's not a good time. This is a function because now it passes the vertical line test. As soon as I put in the bottom part, then it's not a function anymore. All right, so now let's talk about domain. Domain on a circle is kind of nice because you can say, let's say it's a circle that has a radius of 3. Then its domain would be, how far does it go this way? -3. How far does it go that way? 3. So its domain would be from -3 to 3. But why wouldn't we why wouldn't we actually do that? Because the functions, they aren't functions. Circle's not a function. All right. So let's just do a domain of a half circle, because then it actually is a function. It's sort of like a circle. A hemisphere is half of a globe. But you know what a half a circle is called? A hemicircle? All right. Semicircle, very good. Okay, so this is a 3, that'd be a 3, that'd be a 3, in direction anyway. So would you please tell me the domain and range of that circle? Right now, on your paper. Put D, be this. R, be that. Keep the paper open too, so you know, I can see what you're writing. All right. Domain. Flash. What's the domain? There you go. I was going to see if you fix it. There you go. With another bracket? You are correct. And how about the range? In front row. You got it. Okay, so there's domain and range from a picture. Next, let's do domain after that young lady in the blue puts her cell phone on my desk. On my desk. Thank you. We'll do this one. Y equals 1 over x plus 2. For domain, when you don't have a picture, you just ask yourself, what would not work? Everything works except what? -2. So you can say all real numbers except x cannot be -2. You get that? If you do that on a picture, it would be like this. Here's -2. Oops. Here's -2. And it's not working, and everything else works. Why? Why doesn't it work? Because if you put in a -2, it makes you have a 0 on the bottom. Is that okay? No, you can't have a 0 on the bottom. You can have anything else you want on the bottom, but not a 0. All right. So would you please tell me what the domain of this function is? 1 over x plus 3, x plus 2. If you have a question, please don't feel shy about asking it. Just ask it. I won't make you feel bad for your question. Somebody who's asking a question actually cares, and they're not in the middle of texting anybody if they're asking a question, right? So that's a good thing. And they want to know how to do it. So that's all good things. So please ask if you get stuck. All right. So Do you get that we start with all real numbers? Everything works except some things. All right, so pretty much usually there's a lot of things that would work. So the big R just stands for all real numbers. So everything works except what wouldn't work? -3 and -2. So I'd put x cannot be -3 and x cannot be -2. If you'd rather do it this way, here's a number line, and here's where -3 is, here's where -2 is. Doesn't work, doesn't work. But it works everywhere else. So you just go like this. If I really wanted to be sure it worked everywhere else, I could test these intervals. I could like test this point right there would be like at 0. And throw in a 0 and see if it actually works. By working, I just mean it doesn't crash. It doesn't end up with a 0 in the denominator. And this would be 3 times 2, which makes 6. So it would be 1 over 6. It didn't crash, so it works. So it worked in there. So it will work everywhere in there. All right, don't really need to test that kind. This is the kind you need to test. Square root of 3x minus 4. Okay, write that one down. Because this kind, you can't have negatives underneath that root. So here's a new way to do this. Picked up from one of my colleagues. They were saying, instead of just saying, figure out where 3x minus 4 is equal to 0, because that's kind of the key point, and it is important, why not say that whatever's underneath here has to be bigger than or equal to 0. So if I write that, then it's just saying it can't be negative, right? It has to be bigger than 0 or equal to 0. Now, why is that good? Because then, instead of just ending up with x is equal to 4/3, I get x is greater than or equal to 4/3. And the cool part is that 4/3 is still my key point, but I already know where to shade, see? I know I don't have to test both sides. It says greater than, so greater than means this way, so I'm shading that way. See what I mean? And how about the point itself? Well, since it says or equal to, it works. See? So now we're used to doing that kind. I mean, we did a whole bunch of those. So all it does is takes a square root of 3x minus 4 and turns it into this. It's one of those kind of problems. You just got tested on that just the other day. And you set up your little number line, and you can set your final answer is 4/3 to infinity, and that works, and infinity doesn't. All right? Yes. How about 0? Okay, if I stick a 0 in, what's 3 times 0? And then I have a -4, so it's negative. What if I stick in 0? I get -4 underneath the root. Is that okay to have a negative underneath the root? No. So 0 doesn't work. Now 0 is over here somewhere. 0 is smaller than 4/3, so it's over there. So we just tested 0, and 0 does not work, so there you go. Now I know you were thinking 0 is a key point, but the point is not that I stick a 0 in. The point is that this whole thing becomes 0. That's why I set it greater than or equal to 0. So if you got the idea from this, hey, x can't be 0, actually x can be 0. Here I'd want x plus 1 to be 0. Here I'd want like 3x plus 1 to be 0. And now today you'd want that to be 0. So here's your new problem for the day. They give you this, and they say, what's the domain of that? Same exact process. You start by taking what's underneath the root and setting it equal to 0, except I kind of like the new way, greater than or equal to 0. So then I go x squared plus 2x plus 1 is greater than or equal to 0. And now, how do I solve that kind? That's a quadratic. You have 4 ways. You could graph it. You could, what else? Give me something. Factor it. Good. What else could you do? Quadratic formula. There's other ways too. But the big ones you usually use are factoring. I think, I'm convinced that Mrs. Richens loves to factor, because she a lot of times makes these problems up for us on the worksheets or on a test, and a lot of times they'll factor. So, factor them, because that's way easier than quadratic formula. Okay, and then how do I make this number come up with? Only a 1 times a 1 is the only way to make that. And since everything's positive here, I just use pluses, and there we go. I got x equals -1. What is that? That's one of the spots on my number line. There's another -1, but that doesn't really do anything. I still have a negative 1. Now, does that spot itself work, the negative 1? Yes, because it says or equal to. Another way to tell is you actually stick it in here. You'd find out you get a number. When I put in 1, it works, which means this didn't end up negative. It didn't crash. 1 worked. Negative 1 also works. If I stick in negative 1, it will work. So it works. And then since I've got this greater than or equal to thing here, I could probably just assume that this works, but I better really test it. So what's a nice number that's over there? How about 0? 0 is my favorite number for this. Because when I put a 0 in here and here, these parts cancel. Now it's the square root of 1, which is 1. It worked. All that matters is it's not negative. It worked. Okay? So it works over here. And now if I wanted to be extra careful, I could test over here and see if negative 2 would work. So I'm going to go back to this, clean it up a little bit, see if I can stick in a negative 2. Let's see what I get. Stick a negative 2 right in here. And I get 4 plus negative 4, which cancels each other out. Then I have a positive 1 left at the end, so it's a square root of 1. And that works. It didn't crash. So wait a minute. Did I just figure out that this thing actually works over here? Is that possible? So it works everywhere? See what I mean about smart to test it and not just assume? Now I'm thinking, did I do something wrong? But I'm going to go back and look at the original problem here and see, is there anything that would mess this up? Because what I just figured out is it looks like everything will work. Think about it. Can you put in any number that would cause this thing to be negative underneath the root? Like I stick in a negative 10. It seems like it's big enough that it would do some damage. But then this becomes 100, and this is negative 20. You see how this first number is always going to be bigger than this number is? And therefore, it can't be negative underneath it. So we just figured out this one. If this is my graph, it works here, it works here, and it works here. Isn't it working everywhere? Yeah. So this one's domain is all real numbers except nothing. Everything works. All real numbers work. If I put in any number I want, it'll work. So here's the moral of the story. I know you're usually going to have ones where it's like all real numbers except something doesn't work. But if you test your points, we came up with negative 1 as the answer on this one. And you test that point and it works. And you test over here and it works over here. And you test over here and it works over here. Maybe you should look at it closer and everything might work. Yeah, there's no way I can make this come out negative. Impossible. All right. And therefore, everything works. The domain would be all reals. Done. All right. Again, some of the easiest domain questions are the hardest. What's the domain of that one? Can you see that there's no way to crash this? There's no way to make it not work? All right. How about now? Any way to crash it? Nope. Because what you should be doing is setting x squared greater than or equal to 0. And then if we just go through the process and say, okay, well, we solve that, x has got to be 0 is my thing on my number line. But it works at 0. Because if I put in a 0, it's square root of 0, which is okay. And then I could test a number like 1, and it will work. And then a negative 1, it will work. Everything works. So domain's all real numbers. Another way to say it instead of this is this. Negative infinity to positive infinity. I have an extra loop on my infinity there. Okay? All right, so sometimes your domain, you won't have any restrictions. That's more unusual. Usually there are restrictions. All right. Last one. X, I don't know what's y equals. It's supposed to be a y. Y equals that. Try it. phone on my desk. Man, got some chronic texting problems in here. Okay, so first thought, I start by saying that x times x minus 4 has to be greater than or equal to 0. And it's already factored. Cool. So I should be able to get the answer pretty quick. X equals 0 is an important spot. That comes from that. And this one tells me x could be 4, would also be an important spot. Then I go back to my number line. Don't try to do it all in your head. 0, 4. Does it work at 0? Because it says or equal to 0. So yeah, if it becomes 0 underneath there, that's not going to be a problem. So it works there. How about at 4? Works there. Now, would you please test these intervals and get an answer that you are confident is absolutely positively right. Test something negative, test something between 0 and 4, and then test something bigger than 4. I think this is where you guys are weakest, is on the testing part. Okay, so I hope you had a chance to test something like, let's say, 2. Okay? If I stick in a 2, it goes here and here, and will my answer end up being negative underneath there? Yeah, it will, because it'll be 2 times negative 2, and that'll be negative 4. And if I have a negative 4 underneath the root, that's going to be a bad thing. So, didn't work. No work. Okay, now how about something big like 6? Does it work? Yeah, because it's this times this, will be, both things will be positive, so it'll work. As long as your answer underneath is positive, you're in good shape. And how about a really small negative, like negative 10? Have you tested it? Did it work or not? Okay, so let's try one. Let me just show you. Let's say I stick in negative 10 there. And show you. That's negative 14. That's negative 10. Negative 14 times negative 10 would be positive something, so it worked. All right, so there we go. So this one would be from negative infinity to 0, and then 0, then 4 to infinity. Any questions about that one? All right, so today the only thing that happens that is harder is the thing underneath the root ends up being tricky. Let's say it's this. Then you'd have to start this by saying, okay, I want to set this equal to 0, except greater than or equal to 0 would be really smart. Greater than or equal to 0. And then I can factor it if I can. What if it doesn't factor? Quadratic formula. What if you have a graphing calculator? We'll just graph it. Okay, you can graph this side, graph that side, see where they cross. Okay, but on this test, you won't be able to use calculators, so you might as well not get used to that on your homework. I can't stop you from doing it on your homework, but it'd be better if you practice this kind because you'll have no calc spins. All right, so then I'd say 2x and x, and how can I make a 5? Maybe a 5 and a 1. I can tell these numbers are going to be so big, there's no way I'm going to be able to make a middle term of only 3. So it doesn't factor. So let's see who's getting a call. Should I answer? Please don't. I tried to answer and it wouldn't pick up. All right. Moving on. So if I can't factor it, I got to use quadratic formula. Eventually I get down with quadratic formula, and let's say that I got a negative underneath the root, because you would. You did all this work and you found out that x equals negative b plus or minus, and you end up with the square root of negative something. Then there is no answer. How are you going to handle that? Remember, what you're looking for here is exceptions. All real numbers work except what? And if you can't figure out what won't work, it's probably because there isn't anything that won't work. So in other words, look at this. Do you think there's any way to make that negative? There isn't. So if I can't make that negative, then everything works. So all real numbers would work. Pick one. 7. Stick it in there. It'll work. As long as it is negative, it's going to work. Pick negative 10. We did this one before, so it just looked a little different. So if you can't get an answer out, that means nothing. If there's no roots for this, there's no number to test on the number line, then everything works. Just an automatic all real numbers answer. Or negative infinity to positive infinity works. All right, I think that's enough. Now let's do a couple off your worksheet together to get you started. Here we go. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 6. Got your sneaky Android thing. I can't even figure out how to answer the phone call. That would have been fun. 3, 4, 5. 1, 2, 3, 4. I've only successfully been able to answer one phone call that came in during class on the kid's phone, and it was his mom. It's like, Mom? Moms are supposed to know better than to call their kids during the middle of class. All right. Texting would make sense, but tell them to just text you. All right. So let's do number 1, and it says 3 over x plus 2. All right. Oops, wrong button. Just making sure it's still running, and it is. All right, so if I want to find domain is two things. It's whatever's underneath the root has to be bigger than or equal to 0. This doesn't have a root. So then you go to this. That has to equal 0. So how can x plus 2 equal 0 if x was negative 2? So what you're really doing there is setting x plus 2 equal to 0 and solving it. So negative 2 is my answer. Except what a point is all real numbers except what? X cannot be negative 2. And if you rather do that this way, everything works except negative 2. Whichever way you like. Any questions on that one? All right. Let's move on to a more challenging one. Let's look at, for instance, number C, or letter C. 8x squared plus, right away I can see you cannot crash that first term, because you can put in any number you want and it'll never end up with a 0 as a denominator, and there isn't any square root. So that part's good. So then we look at the next part. Plus root negative 2x plus 3. That part could get crashed. So this part right here, I have to figure out what would be, I want negative 2x plus 3 to be greater than or equal to 0. And from there you solve it. Then you'll have your number line, and you put your little special point on the number line, which will work because it says or equal to. So I'll let you figure out what that point is, and then test on both sides of it. See which side actually works. And then you'll know your answer. Okay, so it says algebraically determining domains. It should feel like it's fairly easy for you, I hope. Not super easy, but not too bad. Okay, that's all we got for today.